Hello everyone, my name is Anmol Saini and I am your chemistry SME. Today we are solving BPT 24 chemistry section. Okay, so let's start. So first question is the gram molecule of benzene is equal to. Okay, so we have to calculate gram molecule of benzene. Okay, for this first of all we have to calculate the molecular mass of benzene. We know that the chemical formula for benzene is C6H6. So its molecular mass will be 6 into 12 because atomic mass of carbon is 12, then 6 into 1. So it will be equals to 72 plus 6, which is 78 grams. Okay, and then as per the Avogadro number, the gram molecule of benzene is equals to it, or you can say the gram molecule of a compound is equal to its molecular mass. Okay, so its molecular mass is 78 gram, means its gram molecule will be 78 gram of C6H6, which is 78 gram of benzene. So option number D will be our correct answer. Now comes to question number 52. Under the same condition, nitrogen and oxygen are taken in same mass. Okay, the ratio of their volume will be. Okay, so we have same condition and we are taking nitrogen and oxygen in same mass. We have to calculate ratio of their volume. Okay, so we here we can use ideal gas equation, which is PV is equals to nRT. Okay, so we will use this equation for nitrogen and oxygen. Okay, so N is equals to PV upon RT. Okay. Now we will compare. So here we have same condition. Means pressure will be same, temperature will be same, and rate constant R will be same. Okay. So we have to calculate N and V. So we from this we can find their ratio. Okay. So for N of nitrogen means N2 and N of oxygen means O2. Okay. So their ratio will be N is equals to P, means volume of N2 divide by volume of O2. Okay. So now we have to calculate number of moles of N2. Okay. So we have to calculate we have to calculate V of N2 divided by V of O2. Okay. So mass we have same for both, so we can take it as M, and molecular weight of nitrogen is 28, and we have same mass, so mass of oxygen will be M, and molecular mass of oxygen is 32. Okay, so M will be cancelled out by M, and 32 upon 28 means 8 upon 7, means 8 ratio 7. Okay, so our correct answer is option number A. Now comes to question number 53. The total number of neutrons in di-positive zinc ion with mass number 70 is. Okay. So we have to calculate number of neutrons. Okay. So formula for calculating number of neutrons is equals to atomic mass minus atomic number. Atomic number. Okay. So atomic mass given here is 70, and the element is Zn2 positive. Okay, and its atomic number is 30. So 70 minus 30 is equals to 40. So correct answer will be option number B. Now comes to question number 54. Question number 54. The presence of on one electron each in the 3p subshell of nitrogen is explained by. Okay, so it is saying the electronic configuration of nitrogen is 1s2, 2s2, 2p3. It is talking about 2p subshell. Okay, so 2p subshell. It is saying we have one electron in each subshell. But why it is? Why can't we put two electrons in the same orbital? So this is explained by Hund's rule, because Hund's rule says that the pairing of electron will not be possible until and unless all electrons are singly filled. Okay. So here this can be explained by Hund's rule. So correct answer is option number B. Now question number 55. Rutherford's scattering experiment is related to the size of nucleus, atom, electron or neutron. Okay. So it is related to the size of nucleus. Okay. Scattering experiment is related to the size of nucleus of an atom, The objective of the experiment demonstrate the scattering of alpha particle by gold foil. Okay, so this question is from NCRT line. Directly we have got the NCRT line. Now question number 56. In comparison to a 0.01 molar solution of glucose, the depression in freezing point of a 0.01 molar MgCl2 solution is. Okay. So here we have to compare the depression in freezing point for these two solutions. Okay. So first of all, the formula for depression in freezing point will be delta Tf is equals to I Kf into M. Okay. Now, uh, for glucose, we know that glucose will not further dissociate and associate. Okay. So delta Tf for glucose will be delta Tf for glucose will be I value will be equals to 1 because glucose will not further associate and dissociate. Okay. Now Kf value will be same as Kf, and M value given in the question is 0.01. Okay. So delta Tf will be equals to for glucose 0.01 Kf. Okay. Now we have to calculate for MgCl2. We know that MgCl2 solution will dissociate as Mg2 plus 2 ions of Cl minus. Okay, so there are total 3 molecules in the solution now. So value of I will be equals to 3. Okay, so delta Tf, I value 3, Kf value will be same, Kf, and M value given in question is 0.01. Okay, 0.01. Okay, so now we have to compare for both MgCl2 and glucose. Okay, so value of MgCl2 is 3 Kf into 0.01, and for glucose is 1 Kf into 0.01. So it will be cancel out, Kf will be cancel out, and answer is 3. Okay, so about 3 times will be our correct answer. Now comes to question number 57. Okay, question number 57 is the value of Henry law constant is. Okay, the value of Henry law constant is larger for gases with higher solubility, larger for gases with lower solubility, constant for all gases, not related to the solubility of gas. Okay, so first of all, according to Henry law, we can say that partial pressure of gas is equals to Kh, which is our Henry law constant, into X, which is our solubility. X is our solubility. Okay, now we can write Henry law constant is equals to P upon X, or you can say Kh Henry law constant is inversely proportional to 1 upon X. So when we increase the solubility, then the value of Henry law constant will decrease. Okay, when we increase the value of Kh, the uh, the value of solubility will decrease. Okay, but when we increase the value of solubility, then Henry law constant value will decrease. Okay, so here we have to tell larger for okay, so when the Henry law constant will be larger, it will be larger when the solubility will be less. When solubility will be less, Henry law constant will be larger. Okay, so our correct answer will be larger for gases with lower solubility, option number B. Option number B. Now comes to question number 58. We are given with 4 molecules. Is the molecule we have to find which of the following molecule has the maximum dipole moment. Okay, so first of all, for all these we have to draw their structures. Okay, for CO2, carbon here, and it will be attached with 2 oxygen at this side. Okay, so some electron will be attracted by oxygen, some electron will be attracted by this side oxygen. Okay, so the magnetic or you can say dipole moment will be cancelled out. Okay, so here mu dipole moment will be equals to 0. Now NF3, we have one nitrogen here, F, F, and F here, and one lone pair at the nitrogen. So F will try to attract the electron here. This F will also try to attract, and this F will also try to attract the electrons. And lone pair will also try to attract the electrons. Okay, so this will be all. So all these attraction effect will be cancelled out. Okay, so here also mu dipole moment will be equals to 0. Okay, now in option number 3, we are given with carbon and 4 hydrogen. 4 hydrogen. So this is also symmetrical molecule, means mu will be equals to 0 here. And now for last option, NH3. NH3, we have one nitrogen here attached with three hydrogen and one lone pair. Okay, so here lone pair will try to attract all the electrons. Lone pair will try to attract all the electrons. First, from nitrogen and hydrogen, nitrogen will try to attract, and then from nitrogen to lone pair will also try to attract. Okay, so here the direction of attraction of electron will be this side. Okay, so here mu does not equals to zero. So this is the molecule where we have the maximum dipole moment. So correct answer is option number 4. Now comes to question number 59. Which of these statement is false? Okay, the canonical structure does not have a real existence. Yes, this is true that the we know that canonical structure does not have a real existence. Every AB5 molecule has a square pyramidal structure. No, it is not true. Some AB5 molecule may have a square pyramidal structure, but not every AB5 molecule have a square pyramidal structure. So this statement is false. Electron deficient molecule act as Lewis acid. Yes, this is correct. Multiple bonds are shorter than their corresponding single bond. Yes, this is also correct. We know that single bond, the bond length of single bond will be greater than double bond, and bond length of double bond will be greater than triple bond. Okay. So correct answer is option number 2. Now comes to question number 60. Which of the following is not a characteristic feature of a salt bridge? Okay. Not a characteristic feature. Okay. Salt bridge join the two half of a electrochemical cell. Yes, we know that salt bridge joins the two half. This statement is correct. It completes the inner circuit. It is also correct. It is filled with a solution or gel. Yes, we know salt in salt bridge we have filled with a salt solution or gel. Okay. It does not maintain electrical neutrality of the electrolyte solution of the half cell. No, this statement is false because salt bridge maintain the electrical neutrality. It maintain it maintains electrical neutrality. Okay, it maintains electrical neutrality. So our correct answer will be option number 4. Now question number 61. Which of the following statement regarding primary cell is false? Okay, primary cell cannot be recharged. Okay, so this statement is true that we cannot recharge the primary cell. So this statement is true. They have lower internal resistance. This statement is false because primary cell have high internal resistance. High internal resistance. High internal resistance. They have an irreversible chemical reaction. This statement is true. Their initial cost is cheap. This statement is also true that for primary cell their initial cost is cheap than the secondary cell. Okay. So our correct answer will be option number B because they have high internal resistance. Now question number 62. Question number 62. The enthalpy of crystallization for KCl is minus 715 kilojoule per mole. Okay. The enthalpy of hydration for potassium and chlorine are minus 322 and minus 363 kilojoule per mole respectively. From these value, calculate the enthalpy of solution for KCl. Okay. So we have to find enthalpy of solution for KCl. Enthalpy of solution for KCl. Okay. For this, first of all, we have to calculate the hydration enthalpy for KCl. Okay. Delta H hydration enthalpy for KCl. Okay. So it will be equals to delta H hydration enthalpy of Pa positive and delta H hydration enthalpy of Cl minus. Okay. So hydration enthalpy of potassium is minus 322 and for chlorine is minus 363. So minus 322 plus minus 363 will be equals to minus 385 kilojoule per mole. Kilojoule per mole. And now we have to calculate the enthalpy of solution. Okay. So enthalpy of solution will be equals to enthalpy of solution equals to enthalpy of solution equals to hydration enthalpy delta H of hydration minus and minus of enthalpy of crystallization. Delta H of crystallization, enthalpy of crystallization. So it will be equals to minus 685, then we have minus, and the value of enthalpy of crystallization is minus 715. So minus minus, here will be plus, minus 685 plus 715. So it will be equals to 30 joule, 30 kilojoule per mole. 30 kilojoule per mole. Okay. So our correct answer will be option number 2. Here we have to calculate the enthalpy of solution. Okay. So first of all, we have to calculate the hydration enthalpy. Then we are given with the crystallization. So we can calculate by enthalpy of hydration minus enthalpy of crystallization. So correct answer will be option number 2. Now question number 63. The temperature of the system reduces in N. Okay. So here we have to tell in which of the system the temperature will reduce. Okay. So we have temperature T1 and we have temperature T2. Okay. So while going from temperature T1 to temperature 2 in a process, the temperature T2 will decrease. Okay. So we know in isothermal process, the delta T, the change in temperature is equals to 0. Means here temperature cannot be changed. So option number 2 and option number 3 are incorrect answer. Now we have to check for adiabatic process. Okay. So in adiabatic process, we know that value of Q will be 0 because no heat is exchanged in adiabatic process. So when Q is equals to 0, the first law of thermodynamics state that work will be equals to delta U because value of Q is 0. So our work will be equals to change in internal energy. And we can write work as minus P delta V, which is further equals to NCV delta T, because we want to talk about temperature here. That's why we have to change work in form of delta T. Okay. Now in adiabatic expansion, we know that work is negative. Okay. So work will be negative in adiabatic expansion, means NCV delta T will also be equals to 0, and N and CV can't be negative because N is a number of moles and CV will be a constant. Okay, so they can't be equals to 0 or they can't be negative. Okay, so here we can say delta T will be equals to negative. When delta T will be equals to negative means T2 minus T1 will be negative, or you can say less than 0. When T2 minus T1 will be less than 0, it means that T2 is smaller than T1. Okay, T2 is smaller than T1. So our correct answer will be option number D. Now comes to question number 64. Activation energy is, okay. So here we have to tell the definition of activation energy. Okay. The amount of energy to be added to the actual energy of a molecule so that the threshold energy is reached. Okay. So this is the correct definition of activation energy. Okay. So actual energy of a molecule, we have to add the threshold energy, the amount of energy that is required to initiate a reaction. Okay. So this is the activation energy, or you can say the required energy to initiate this reaction. Okay. So correct answer will be option number A. This is the definition of activation energy. Now question number 65. We have the chemical reaction R to P plus Q. Okay. Now its rate can be defined as, we have to tell its rate. Okay. Rate of decrease in concentration of R per unit time, means R is reactant here and P and Q are product. Okay. So it is saying rate of decrease in concentration of R per unit time. Okay. We know that in a chemical reaction, the rate of concentration will decreases after some time, or you can say per unit time. Okay. And the rate of and the concentration of P and Q will increase per unit time. Okay. So option number 1 is saying that its concentration will decrease after some time. So this option is correct, that its rate will decrease or its concentration will decrease. Rate of increase in concentration of R. No, rate of the reactant, or you can say the concentration of reactant cannot be increased because the reaction will move in forward direction. Okay. So the concentration of R will decrease. Rate of increase in concentration of P and Q collectively per unit time. Okay, so it is not necessary that both product concentration will increase. If either one of their concentration will increase, then it also satisfy the condition. So collectively is wrong. Rate of decrease in concentration of R in 5 minutes. It not necessary that it will uh, decrease up to 5 minutes. It can last longer than 5 minutes, or the reaction may complete in 2 minutes or lesser than that. Okay, so this option is also incorrect. So correct answer is option number E. Now comes to question number 66. Collision theory provides a greater insights into energetic and mechanistic aspect of reaction. Yes, this is correct statement. Here we are given with two statement, and we have to tell which statement is correct and which is incorrect. And statement 2 is the correct explanation or not. Okay. So statement 1 is collision theory provides a greater insight into the energetic and mechanistic aspect of reaction. This is absolutely correct, that collision theory provides the information about its energy, its mechanism, and everything. And collision statement number 2, collision theory has no link with kinetic theory of gases. This statement is false, because collision theory and kinetic theory, from both we can find the number of collision, the kinetic energy of the molecule after collision. Okay, so collision theory is linked with kinetic theory of gases, so that we can find many things: kinetic energy, number of collisions, and much more. So statement 2 is incorrect. So correct answer will be statement 2 is correct, statement 1 is correct, and statement 2 incorrect. So option number C is our correct answer. Now comes to question number 67. Here we are given with two statements, and we have to tell which of the following is correct and whether statement 2 is correct explanation of statement 1. Okay. So statement 1, the rate law may not depend on the concentration of every reactant. Okay. So let's suppose the reaction P plus Q gives X plus Y. Okay. So here the rate law may not depends on the concentration of every reactant. This statement is correct because rate law may include only one of the reactant in its equation. Okay, so it is not necessary that both of the reactant or the total number of reactants will be included in the equation of rate law. Statement 2, with increase in temperature, rate of reaction increases. Okay, so this statement is also correct because when we increase the temperature, the rate of reaction increases up to an extent, but after that extreme point, it started decreasing. Okay, so but statement 2 is also correct. Okay, but statement 2 is not the correct explanation because it is not talking about rate law. Okay, so statement 1 is true, statement 2 is also true, but not the correct explanation. Means option number B is our correct answer. Now question number 68. Lithium is strongest oxidizing agent among the alkali metals. Okay. So we have alkali metals as hydrogen, lithium, sodium, potassium, rubidium, and cesium. Okay. And among this, helium is the one which has the strongest reducing agent. Okay. So this statement is correct. And here we have to tell the incorrect statement. Now, alkali metal reacts with water to form hydroxide. This statement is also correct, that all these will react with NaOH to form corresponding hydroxide. Okay, means Na will react with OH to give NaOH. Similarly, K will react with OH to give KOH. Okay, so statement 2 is also correct. So oxidation number of K in KO2 is 4. Okay, here CO2. But here oxygen has the oxidation number of -1 by 2, because here oxidation is present, because here oxygen is present in its superoxide state. Superoxide state. And in superoxide state, the oxidation number of oxygen is -1 by 2. Okay, -1 by 2. And we have two molecule of oxygen, means total charge on oxygen will be -1. When total charge on oxygen is -1, then correspondingly the charge on potassium will be +1. Okay, because both positive and negative should be balanced here. Okay, so charge will be +1, not +4. So this is our answer and the incorrect statement. Now option number 4, the ionization enthalpy of alkali metals decreases from top to bottom in the group. Yes, this statement is correct. Generally, the ionization enthalpy increases from going left side to the right side and decreases from going top to the bottom. Okay, so C is our correct answer. Now question number 69. In acid solution, the reaction we are in acid solution, the reaction 2MnO4 minus will gives Mn2 plus. Okay, so here we have to tell whether there is oxidation of how many electron, whether there is oxidation reduction, and how many change of electron is there. Okay. So here first of all we can see that oxidation state of Mn is x minus 8, sorry, x minus 8 is equals to minus 1. So x is equals to 7. Means on the reactant side Mn is plus on, will present on plus 7 oxidation state, and it is going to Mn plus 2 oxidation state. So here we have reduction. Here we have reduction because from higher oxidation state we are coming to lower oxidation state. So we are there is change in reduction. So answer will be option number B or option number D. Okay. So we have to calculate now how the change in electron. Okay. So there is 5 change in electron. Okay. 7 minus 2 is equals to 5. There is 5 electron change. So correct answer will be option number D, because we have reduction here and change by 5 electron. Okay. Now question number 70. The pH of 0.01 molar NaOH solution will be. Okay. So we are given with the concentration of NaOH, means concentration of OH minus will be equals to 10 raised to power of minus 2 molar. Okay. So now we have to find pH. Okay. So we can take pOH. When we will take pOH means minus log of 10 raised to power of minus 2. 10 raised to power of minus 2. Okay. So when we solve this, it will comes out to 2. So pOH value will be equals to 2, and we know that pH plus pOH will be equals to 14. Okay, so when pOH value is 2, then pH value will be equals to 12 minus 2, which is equals to 14 minus 2, which is equals to 12. Okay, pH is 14 minus 2, which is equals to 12. Okay, so the value of pH will be option number C, 12. Now question number 71. How many liter of water must be added to 1 liter of aqueous solution with a pH of 1 to create an aqueous solution of pH of 2? Okay. So first we are given with pH 1 and we are given with pH 2. Okay. So here the concentration of H plus will be equals to 10 raised to power of minus 1 molar. Okay. And here the concentration of H plus will be equals to 10 raised to power of minus 2 molar, because we know pH is equals to minus log H plus. From this we can calculate the concentration of H plus, which is equals to 10 raised to power of minus 1 and 10 raised to power of minus 2. Okay. And how many liter of water must be added to 1 liter of, okay. And we are given that the volume of solution, and the volume of solution which having pH 1 will be equals to 1 liter. And we have to calculate the volume of second. Okay. So we know that M1 V1 will be equals to M2 V2. So we can use this formula and calculate. Okay. For solution 1, we are having concentration 10 raised to power of minus 1 and volume 1 liter. Okay. For solution 2, concentration is 10 raised to power of minus 2 and volume is V2. Okay. So we can calculate V2 as 10 raised to power of minus 1 divided by 10 raised to power of minus 2. Okay. So it will comes out to be V2 equals to 10 liter. Okay. V2 is equals to 10 liter. And here we have to tell how many liter of water must be added. Okay. So water or you can say volume of water to be added will be equals to 10 minus 1, which is equals to 9 liter. Okay. Because we have to subtract 1 liter from the solution 1. Okay, so it will becomes out to 10 minus 1 is equals to 9 liter. So correct answer will be option number 2. Now question number 72. Which of the following statement is incorrect about chemical equilibrium? Okay, first is chemical equilibrium is attained whether we start with reactant or product. This statement is correct. that whether we will start with reactant or product, the chemical equilibrium will attain after a certain period of time. Okay, and here we have to calculate the incorrect statement. Chemical equilibrium is dynamic in nature. Yes, this statement is also correct. Chemical equilibrium, we are given with reaction CaCO3 solid will give out CaO solid plus O2 gas. Okay, is heated in an open vessel. Okay, chemical equilibrium we are given with the equation is heated in an open vessel. Okay, so if we heat this reaction in an open vessel, then O2 gas will be separated out. When gas will be separated out, the chemical equilibrium can't be attained. Chemical equilibrium cannot take place in open vessel if one of the reactant or product is gas, because it will be separated out. Okay, so this is an incorrect statement. Now option number 4, at equilibrium, the concentration of each of the reactant and product become constant. Yes, this is correct. That after a certain period of time, the when equilibrium is attained, the concentration of both reactant and product is uh, and reactant and product become constant. Okay. So correct answer is option number 3. Now comes to question number 73. Question number 73. Okay. So here we have to calculate the spin only magnetic moment of Fe F6 3 minus. Okay. So first of all, here we have to calculate the oxidation number of iron. Then we have to calculate the number of unpaired electron. And from the number of unpaired electron, we know magnetic moment will be equals to n into n plus 2. Okay. So first of all, oxidation state of Fe. So we can take as x minus 6 will be equals to minus 3. Okay. So x will be equals to 3. Means Fe is present in Fe plus 3 state. Okay. Fe plus 3 state. So now we have to calculate the electronic configuration for Fe3 plus. So for Fe, the electronic configuration is 4s2 3d6. Okay, so here we have to remove 3 electrons. Means 2 electron will be removed from this and 1 will be removed from this. Okay, so it will become 3d5. Okay, 3d5 means 3d5. 1, 2, 3, 4. 1 electron, 2 electron, 3, 4, and 5. Means we have 5 unpaired electron. Okay, so when we have 5 unpaired electron, mu will be equals to under root 5, 5 plus 2, which is 7. So root 35. So root 35 is approximately equals to 5.9. Okay, because root 36 is equals to 6. Okay, so correct answer will be equals to option number A, 5.9 Bohr magnetron. Now question number 74. The E naught value for the Mn3 plus to Mn2 plus is Mn2 plus couple is more positive than Cr3 plus to Cr2 plus or Fe3 plus to Fe2 plus due to change of. Okay, so due to change of which of the following configuration this is more positive. Okay, so first of all, here we have to calculate the electronic configuration for manganese, which is 4s2 3d5. Okay, for Mn2 plus, here 2 electron will be removed, means here the concern it will become 3d 3d5 3d5. Okay, and for Mn3 plus, the electronic configuration will be equals to 3d4. Okay, 3d4. And it is saying for while going from Mn3 plus to Mn2 plus. Okay, so means here electronic configuration will be 3d4 and here electronic configuration will be 3d5. Okay, so it is going from d4 to d5 configuration. That's why it is more positive than the Cr3 plus going to Cr2 plus or Fe3 plus going to Fe2 plus. So value of E0 will be more due to the change in D4 to D5 configuration. So correct answer is option number A. Now question number 75. Urea reacts with water to form A. Okay. So first of all, the formula for urea will be NH2 CO NH2. This is the chemical formula for urea. When urea reacts with water, it will give a compound A. The compound A is shown here. NH4 whole twice CO3. Okay. which will decompose to B. Okay, when we heat this, it will decompose to B. It will decompose to B means it will give NH3 gas. Okay, it will give NH3 gas. It will give NH3 gas, and the we have byproduct as well in form of CO2 and H2O. Okay, now it will decompose to B when passed through the Cu2 plus aqueous solution. A deep blue colored solution C is formed. Okay, so when NH3 will be passed to Cu2 plus aqueous solution, then a blue colored compound will form. Blue colored compound will form. Blue colored compound will form, uh, which is shown here as C. What is the chemical formula for C from the following reaction? Okay, so when we react NH3 with Cu2 plus solution, Cu NH3 whole 4, two positive compound will form. Okay, and it the color of this solution is blue colored solution. Okay, so correct answer will be option number A, and this reaction is very important in point of in terms of board exam, in terms of neet exam. Okay, so please learn this reaction very carefully. This is very important reaction, very important reaction. Now question number 76. in comparison in comparison with boron, the beryllium has. Okay, so we are given with boron and we are given with beryllium. Okay, so we have to comment on the ionization enthalpy and nuclear charge. Okay, for ionization enthalpy, first of all, we can write their electronic configuration. Okay, so atomic number of boron is 5 and beryllium is 4. Okay, so 1s2, 2s2 means its electronic outermost configuration will be 2s2, and its the outermost configuration for boron will be 2s2, 2p1. Okay, so uh, the comment on ionization enthalpy. Okay, so here beryllium has a fully filled stable orbital, and boron has not that stable orbital because we know that half filled and fully filled orbitals are more stable. So here beryllium the here the electronic configuration of beryllium is more stable, so we require more ionization enthalpy to remove the electron from the beryllium. Okay, so the in comparison to boron, beryllium has. Okay, so beryllium has the greater ionization enthalpy, and we have the greater ionization enthalpy. Okay, so the second thing is nuclear charge. Okay, nuclear charge, we know when we grow from the left side of the periodic table to the left to the right side of the periodic table, the nuclear charge decreases. Okay, nuclear charge decreases means correct answer will be option number C, because from the left side, while going from the left side to the right side, nuclear charge decreases, and the ionization enthalpy is greater for beryllium because of its stable electronic configuration. Now question number 77. Valency of which of the following element is not equals to the valence electron? Okay, so we have to calculate valency and valence electron. Okay, so first of all, here let's calculate valency. Na, Mg, carbon and oxygen. We know that valency of nitrogen will be equals to 1, and for magnesium its valency will be equals to 2. For carbon we know it's 4, and for oxygen the valency will be equals to 2, because valency will be just equals to the charge, the maximum charge which can be present on the uh, atom. Okay, so Na can exist in Na plus, magnesium can exist in Mg2 plus, carbon in 4, and oxygen in 2 minus. Okay, and now we have to calculate the valence electron as well. So valence electron, you can say outermost electron. Okay, so the outermost electron for Na will be 3s1. Okay, similarly for magnesium will be 3s2. I am just writing the outermost electronic configuration. For carbon, atomic number 6 means 1s2, 2s2, 2p. Atomic number 6 means 1s2, 2s2, 2p2. Okay, so here we are given we have the electronic configuration as 1s2, 2s2 and 2p2. Okay, so the number of valence electron or the outermost electron will be equals to 4. Okay, outermost electron will be 4, because in outermost shell both 2s2 and 2p2 is present. Okay. Now for oxygen, the electronic configuration will be 1s2, 2s2, 2p4, 2p4. Okay. So now the outermost electron or the valence electron will be equals to 6. Okay. So which of the in which of the following the number is not equal? Here 1 is equals with 1. This is correct. Ng is also correct. Here 4. So the incorrect answer will be oxygen. Which of the following is not equal? The valency of which of the following element is not equals to valence electron? So this is true for oxygen. Now question number 78. The number of element present in each period is equals to. Okay, so this is a theoretical question that the number of element present in each period is generally equals to twice the atomic orbital available in the energy level in which an electron is filled. Okay, so this is the correct answer. Now question number 79. Which of the following has been arranged in order of the decreasing bond dissociation energy? Okay, so we know that bond dissociation energy is inversely proportional to bond length. Okay, so when the bond length will be higher, the bond dissociation energy will be lower. Okay, and vice versa. Okay, so first of all we have to check the order of bond length, then we will calculate order of bond dissociation energy. Okay, so for sulfur oxygen, then we have oxygen chlorine, and then we have sulfur oxygen. Okay, so oxygen is common in all. So we have to check the atomic radius of phosphorus, chlorine, and oxygen. Okay, for this from these we can check that phosphorus has the highest atomic radius. Okay, then followed by sulfur, then chlorine, because the general trend for atomic radius is when we go from the left side to the right side, atomic radius decreases, and when we go down the group, atomic radius increases. Okay, so this is the order of bond length, and the order of bond dissociation energy will be just opposite, means this side and this side. Highest for OCl, highest for OCl means correct answer will be option number 4. Okay. Now question number 18. Question number 18. PCl3 upon hydrolysis gives an oxo acid of phosphorus. The basicity of that oxo acid is. Okay. So we are given with PCl3 and hydrolysis means H2O. When we will react PCl3 with H2O, it will form oxo acid of phosphorus, which is S3PO3, and the HCl its byproduct. Okay. Now we have to calculate the basicity of this oxo acid. Okay, so we know that basicity of the oxo acid of phosphorus are in order. When for S3PO2 it will be equals to basicity will be 1. For H3PO3 basicity will be equals to 2. When for H3PO4 the basicity will be equals to 3. Okay, now here we are given with H3PO3 means the basicity of oxo acid will be equals to 2, means correct answer will be option number 2. Now question number 81. The IUPAC name of the following compound is. Okay, so here we have to find the IUPAC name of this compound. Okay, CH3, C, CH3, CH3, and CH3. Okay, so numbering will be 1, 2, 3. Okay, so there are two methyl group at the position 2. Okay, so it will be 2 comma 2 dimethyl, 2 comma 2 dimethyl, and then we have propane group. Okay, so it will be 2 comma 2 dimethyl propane. Okay, this is very easy question. So correct answer will be option number 3. Now question number 82. Question number 82. This is the answer for this compound. Okay. Now question number 82. Here also we have to find the correct IUPAC name of the compound. Okay. So we have fluorine, then carbon, carbon, then we have ET group. ET group means we have CH2, CH3 group. CH2, then we have CH3 group. Then NO group attached here, then NO2 group, now Br group, iodine group, and hydrogen group. Okay, now, so first of all, we have to do the numbering in such a way that the groups will get the lowest possible number. So numbering will be like that: one number, two, three, and four. Okay. Now we have to write the name in alphabetical order. Okay. So first of all, we have to write for bromine. Okay. So bromine is present on two numbers. So 2 bromo, 2 bromo. Then we have fluorine. Then so 1 fluoro, 2 bromo, 1 fluoro. Then we have iodine. So iodine and iodine on number one. So one iodo, one iodo. Then we have four nitro group as well. So it will be two nitro, and the total number of carbons are four. So propane. Two nitro. Also, total number of carbons are four. Then we have butane, not propane. Okay. So it will be butane. So correct answer will be option number third. 2 bromo, 1 fluoro, 1 iodo, 2 nitro, butane. Okay, so correct answer option number 3. Now question number 83. Question number 83, which of the following statement is correct? Okay, so which of the following statement is correct? First, we have aryl carbocation is more stable than propyl carbocation. Okay, so the structure of aryl carbocation is CH2, double bond CH, single bond CH2. Then we have positive charge on CH2. And structure of propyl is propyl. We have CH3, CH2, CH2, and then plus charge. Now we have to find which of the following is more stable. So here we can find double bond, single bond, positive. Means some resonance is occurring in this because we have conjugation over there. So it can so due to resonance, aryl is more stable than propyl. So correct. So option number one is correct. Now second, ethyl carbocation is more stable than allyl. Okay. So structure of ethyl carbocation will be CH3, CH2 plus ethyl and aryl. The structure of ethyl will be CH3, CH2 positive. Now we have to compare between ethyl and aryl. So again we can see that in allyl there is a double bond, single bond positive. Means some resonance is occurring here in this. So due to resonance, aryl is more stable. So this statement is incorrect. Now vinyl carbocation. The structure of vinyl carbocation is CH2, double bond CH plus, and we have to compare between vinyl and ethyl. Okay, so between vinyl and ethyl, due to positive charge, due to positive charge and due to double bond, it is more unstable because double bond is tied to attracting more electron. Okay, so ethyl carbocation is more stable. So this statement is also incorrect. So our correct answer will be option number one. Now question number 84. Question number 84. Out out of the given two isomer, which property for second is greater than first? Okay. So which property is greater than second? Also, we have to tell which property of second is greater than one. Okay. So first of all, dipole moment. Okay. So we can see in structure one, it is cis isomer and this is trans isomer. This is trans isomer. Okay, so in cis isomer we can see that both methyl group, both CH3 group can donate electron to this side. So mu value, that is dipole moment, will not be equals to 0. But here one CH3 is present at the top side and another CH3 at the bottom side. So it is trans isomer, so it will cancel out mu. So dipole moment will be equals to 0 because electron direction will be cancelled out. So it can't be our option. Now boiling point. We know that cis isomer have higher boiling point. Cis isomer have high boiling point than trans. High boiling point than trans isomer. Okay. So this is also incorrect. Solubility in H2O. Okay. So generally solubility in H2O, solubility in water in H2O is also higher for cis isomer than trans. Okay. Now melting point. Now for melting point, trans isomer is has the higher melting point than cis isomer. Okay, so correct answer will be option number 4. Now comes to question number 85. Question number 85. According to Vesper theory, which of the following structure is exhibited by methane? Okay, so chemical formula for methane is CH4 and structure for it will be uh, this H and H. Okay, so it will be AB4 type molecule. AB4 type molecule, and the structure for AB4 type molecule is tetrahedral structure. So correct answer will be option number 4, tetrahedral. Now question number 86. Question number 86. Dihedral angle of least stable conformer of ethane is, okay. So we know that there are two conformers of ethane which are eclipsed and staggered, okay. This is eclipsed and this is staggered, okay. So eclipsed conformer is least stable while staggered conformer is more stable. In eclipsed conformer, the dihedral angle is 0 degree. So you can see the dihedral angle is here, which is 0 degree, because these are identical. This H and this H are identical. Okay. So here dihedral angle is 0. Dihedral angle is 0. But in the staggered conformer of ethane, we have 60-degree angle between them. 60-degree angle between them. Okay. So and staggered is more stable than eclipsed, more stable. So correct answer for this will be 0 degree, because the least stable is eclipsed isomer and its dihedral angle is 0 degree. Now question number 87. Which among the following compound show geometrical isomerism? Okay, for showing geometrical isomerism, when we have carbon double bond carbon, if a group attached to this side is A, then the opposite group should be B. These group must not be equal. If these group are same, then it will not show geometrical isomerism. Similarly, if their compound is A, then it should be B. Okay. So first question is pent 1E. Okay, pent 1E. So we have to draw structure for pent 1E, which is 1, 2, 3, 4, 5 carbon, and it will and double bond is present on one number. Okay, so one group is present at the right side is H, another group is also H. So these two group are same, means it will not show geometrical isomerism. Okay. Now for compound 2, 2, 3 dimethyl butene. Okay, so butene. Now 2 comma 3 dimethyl means CH3 and CH3. Okay, so there is carbon double bond carbon. This group and this group are same, means it will not show geometrical isomerism. Similarly, we can check for 3 and 4. Okay, let me check for option number 4. We have hex, means 6 carbon chain, 6 carbon chain. Then we have double bond at the third position, and then we have 3 and 4 methyl. Okay, CH3 group at 3 position and CH3 group at 4 position. Okay, so now here we can see here is our carbon double bond carbon. So one group is ethyl and another group is methyl. Okay, so these two group are different at the right side. Now we have to check for left side. Here we have ethyl and here we have methyl. These two group are also different. Okay, so it satisfies the condition of geometrical isomerism. So compound 4 will exhibit geometrical isomerism. Now question number 88. The second and third row element of transition metal resemble each other more than they resemble the first row because of, okay. So they resemble more in second and the third row of the transition metal. It is due to the lanthanoid contraction. Okay, due to lanthanoid contraction. Lanthanoid contraction. Okay. Now option number A, lanthanoid contraction, which result in almost same radii of the second and the third row metal. This statement is absolutely correct. Okay, and this is our correct answer as well. So now question number 89. We have uh, question number 89. Fe3 positive compounds are more stable than Fe2 positive compounds because, okay. So we have to tell why Fe3 positive compounds are more stable than Fe2 positive. Okay. So first of all, we have to write electronic configuration, then we can predict. Okay. So we have Fe3 positive and we have Fe2 positive. So first of all, we can write electronic configuration for Fe, which is 4s2 3d6. Now for Fe2 positive, it will be 3d6. For Fe3 positive, it will be 3d5. Okay. So if we draw the orbital diagram, then we can see 1, 2, 3, 4, 5. For 3d5, 1, 2, 3, 4, 5. Okay. So we have half filled orbital for 3d5, half filled orbital. And for 3d filled, it is not the half filled. Okay. And we know that half filled and fully filled orbital are more stable. Half filled and fully filled orbitals are more stable. That's why Fe3 positive compounds are more stable. Okay, so the reason will be Fe3 positive has 3d5 configuration, which is half filled. Okay, so B will be our correct answer. Now question number 90. Question number 90. In which of the following compound manganese has the oxidation number equal to that of iodine in KiO4? Okay, so we have to check the oxidation state of iodine in KiO4. Okay, so oxidation number of potassium is 1. For iodine we can take as X. For oxygen it will be -8 because of 4 oxygen molecule, which will be equals to 0. So X it will be equals to 7. Okay, so means iodine here is present in +7 oxidation state. And now we have to check for potassium manganate, potassium permanganate, and these. Okay, now for potassium manganate, we know that the formula for potassium manganate will be K2MnO4. Okay, K2MnO4. Okay, so 2 plus X minus 8 will be equals to 0. Okay, so for option number 1, the oxidation state will be +6. Okay, now for option number 2, we have potassium permanganate, which is KMnO4. KMnO4 means 1 plus X minus 8 equals to 0, X equals to 7. So this will be our correct answer, option number B. Now check for option number C. The formula will be Mn twice CO whole 10. Okay, so here the oxidation state of manganese is 0, or you can say oxidation number is 0 because the charge on CO will be 0. Here it will be 0, here +7. Now for manganese chloride, the formula will be MnCl2. For MnCl2, Mn will be present in +2 oxidation state. Okay, +2 oxidation state. So the oxidation state of iodine is +7, and which is equal to the oxidation state of manganese in potassium permanganate. So option number B is our correct answer. Now check for question. Now we have to check question number 91. The correct order of number of unpaired electron is. Okay. So here we have to find out the order of unpaired electron. For Cu, then Ni, then chromium, then Fe3 positive. Okay. Let's find for Fe3 positive. Okay. So the outermost electronic configuration for Fe3 positive will be 3d5. When we have 3d5 means number of unpaired electron will be 5. Okay, now for chromium 3 positive, Cr3 positive will be for chromium the electronic configuration is 4s1 3d5. When we remove 3 electrons, configuration will become 3d4, means number of unpaired electron will be 4. Okay, now for Ni2 positive, Ni2 positive we have 4s2 3d8. When we remove 3 electron it will become 3d8. So number of unpaired electron will become 2. Now for Cu2 positive, electronic configuration for Cu is 4s1 3d10. When we remove 2 electron it will become 3d9. So number of unpaired electron will be 1. Okay, 1 electron. So number of unpaired electron will be 1. Okay, so the highest will be for Fe, then for chromium, then for nickel, then for copper. So correct answer will be option number C. Now comes to question number 92. The highest oxidation state shown by actinides is. Okay, so generally actinoid state, uh, it they show +3 oxidation state, but they can show wide range of oxidation state which can range from +3 to +7. Okay, so the highest oxidation state shown by them is +7, which can be shown by Np and Po, and they can exhibit oxidation state of +7. So correct answer will be option number 2, which is +7 oxidation state. Now question number 93. Question number 93 is, phenol is more reactive than benzene towards electrophilic substitution reaction. This statement is correct that phenol is more reactive than benzene, and this is due to the reason because phenol has plus M group attached with it, which is OH, and we know OH is strong plus M effect group. And the reason is, in case of phenol, the intermediate carbocation is more resonance stabilized. Yes, this the reason is also correct, because uh, phenol will form phenoxide ion, phenoxide ion, and its intermediate product is more resonance stabilized due to the benzene ring. Okay, so due to the more stabilized resonance, it will be more stable. Okay, so the we have assertion is correct, we have reason is correct, and the assertion is correct, and the reason is correct explanation of assertion. Okay, due to the resonance stabilized, the phenol can is more reactive towards electrophilic substitution reaction. Okay, so correct answer will be option number E. Now question number 94. In case of phenol, bromination take place even in absence of Lewis acid, whereas bromination of benzene take place in presence of Lewis acid like FeBr3. Yes, this assertion is correct. That bromination of phenol can take place without Lewis acid. Okay, its bromination can take place similarly by this reaction. But for benzene, we have to use Br2 in presence of Lewis acids such as FeBr3. Okay, this statement is correct, and the reason is OH group attached to the benzene ring is highly deactivating. Okay, but the reason is wrong, because we have discussed that the phenol group is more activating group due to the plus M effect. It is more activating group, more activating group, and due to the more activating group, we do not require the Lewis acids such as FeBr3. Okay, so the reaction can easily take place by phenol by reacting with bromine gas. Okay, so the correct answer will be option number C, because assertion is correct but reason is incorrect. Now question number 95. CH3, CONH2 and CH3, CH2, NH2 can be distinguished by reacting. Okay, so here we are given with CH3, C double bond O NH2, and then we are given with CH3, CH2, NH2. And now we have to tell how we can differentiate these two. Okay, so when we will react these two by NaOH in presence of heat. Okay, so this C double bond O group, due to this group, it will release NH3 gas, ammonia gas, CH3, C double bond O NH2. Due to C double bond O group, when we react with base sodium hydroxide, it will release NH3 gas, ammonia gas. But in CH3, CH2, NH2, there is no C double bond O group. Hence, the reaction will does not take place. Okay, so we can easily differentiate by reacting with sodium hydroxide in presence of heat. So option number one is correct answer. Now question number 96. Which of the following alkane cannot be made in good yield by Wood's reaction? Okay, so we know from Wood's reaction we can produce symmetrical alkene, symmetrical alkene, symmetrical alkenes in good amount, in good amount or good amount. But in Wood's reaction we can't produce unsymmetrical alkene. Okay, so here we have to find out in these four which of the following is unsymmetrical, that will be cannot produce by Wood's reaction. Okay, so first of all we are given with 2,3 dimethyl butane. Okay, so butane, then 2 comma 3 dimethyl, now cs3 group here and cs3 group here. Okay, so this is symmetrical when we see from this side the same group here and the same group here. So this is symmetrical. It can't be our answer. Now we have to check option number two, N-heptane. N-heptane means 7 carbon chain. 1, 2, 3, 4, 5, 6, and 7 here. Okay, so it cannot be. We cannot make symmetrical compound. If we cut from here 3 carbon and here 4 carbon. If we cut from here 3 carbon and here 4 carbon. So this is unsymmetrical compound, this is unsymmetrical alkene, so it can't be formed by Wood's reaction. Okay, so if we check option number 3, we have N-butane means 4 carbon chain, 1, 2, 3, 4. So it is this is symmetrical. This group 2 carbon, this group has also 2 carbons. So option number 3 has also symmetrical group. Now N-hexane. N-hexane means we have 6 carbon chain, so we can easily divide it into two groups of three carbon. Okay, so this is also symmetrical compound. So option number 2 is our correct answer. Okay, now question number 97. Okay, question number 97. Okay, so question number 97. The alkane that gives only one monochloro product on chlorination with in presence of diffuse sunlight is. Okay. So we have to tell from the following which one will give only one monochloro product. Okay. So first of all, this can be easily just by looking at the option. So here we are given with the neopentane. We know that neopentane is surrounded by 4 methyl group, means CS3 here, CS3 here, CS3, and here CS3. Okay. So if we react it with Cl2 in presence of sunlight, in presence of H mu, the Cl can be added at any position. We can remove H from here, here, and here, and we can add Cl at any of the four position. Okay, so these all will give only one type of compound, which is shown in this reaction. Okay, it will be uh, Cl. We can remove this and CH2 Cl. So it is the only one which can give only one monochloro product. Okay, so option number 2 will be our correct answer. Okay, now question number 97. Question number 97. Acetophenone can be converted to phenol by reaction with. Okay. So first of all, we have to draw the structure of acetophenone, benzene, C double bond O, and CH3. This is the structure of acetophenone, and we have to make phenol from this. Phenol. Okay. From acetophenol to phenol, this can be done by the reagent meta chloroperbenzoic acid, which is MCPBA, which is its full form is meta chloroperbenzoic acid, and this is a important name reaction, and the name is Bayer Villiger oxidation reaction. Oxidation reaction. This is a very famous name reaction in which we can directly convert acetophenone to phenol by the help of meta-chloroperbenzoic acid, and after this we have to follow base catalyzed hydrolysis. From this we can directly convert acetophenone to phenol. Okay, so option number 1 is our correct answer. Now question number 99. Here we are given with aniline and we have to find out A and B. Okay. So aniline and we are given with A and B. Okay. So from aniline we are directly converted to diazonium salt. Okay. So we can convert aniline to diazonium salt by the reagent NaNO2 in presence of HCl. This is the reagent which can convert aniline to diazonium salt. Okay. So A is NaNO2, comma HCl. Okay. And now when we will react diazonium salt with CuCN, then Cn will then here N2 plus and Cl minus, it will be replaced by NH2 group. Means again it will be converted to aniline group. Aniline group. Aniline. And aniline is the common name, and it's you can say IUPAC name will be uh, benzonitrile. Sorry, benzonitrile. So our correct answer will be option number 3, which is A is NaNO2 in presence of HCl and followed by aniline, which can be also named as benzonitrile. So option number 3 will be our correct answer. Now last question, question number 100. Among the given compound, the compound which is oxidized to prepare methyl ethyl ketone is. Okay. So we have to make methyl ethyl ketone. Okay. So here we have ethyl group followed by ketone group and CH3 group. So this is methyl, ethyl, and then ketone. So we have to make this. Okay. By the following reagents. Okay. So which of the following reactant we can form this? Okay. So first of all, we can convert. We have to make ketone. Okay. So we know that we can easily convert 2-degree alcohol to ketone by its oxidation. And oxidation we can use PCC and PDD. PCC and PDD. So it can directly convert 2-degree alcohol to ketone. So we have to find among the four options which has 2-degree alcohol. Okay. So if we carefully look at option number 2, which is butane 2 all, 1 2 3 4, and all at the second position. So this is a 2-degree alcohol because the OH group is attached to carbon and this carbon is attached to two carbons, means it is a 2-degree alcohol. So this 2-degree alcohol can be directly converted to ketone in presence of PCC, or you can say PDD, which will oxidize 2-degree alcohol to ketone. Okay, so option number 2 will be our correct answer. Okay, so hope you will understand every question. So thank you so much.